Griffith's forest ecosystems are also very important carbon sinks and stocks, and just let me explain what I mean by that. About 2/3 of the additional greenhouse gases in the atmosphere are from humans burning fossil fuel, coal, oil and gas. The other third actually comes from deforestation and degradation. So we've got two problems when it comes to mitigating greenhouse gas emissions. We have to rapidly transit from using fossil fuel as a source of energy to clean energy sources like wind and solar, tidal maybe, and others. And we have to stop emissions from deforestation and degradation. So, and this is where forest ecosystems come in. So how does the carbon get into forests? Well, it's a natural process, isn't it? So when you look at any plant, actually, if you take out the water, half the volume, half the mass, I should say, of what you're looking at is carbon. So plants absorb carbon dioxide and they use that carbon in photosynthesis to produce sugars, and that's the carbohydrates, that's the building blocks for biomass. So when we look at a forest ecosystem, half is what you're seeing as carbon. In terms of the living biomass, the vast majority is stored in the woody stems and branches and roots of big old trees. So the older a tree gets, the more carbon it amasses. So what's really important is how much carbon is kept out of the atmosphere for how long. So it's the accumulating aggregate stock of carbon that's important. But not only is there carbon in the living tree, there's also carbon in the dead biomass. So when the tree dies and falls over, that carbon hangs around there for a long time. And then a proportion of that goes into the soil, gets incorporated in the soil. In fact, all plants and trees in particular, in fact, any woody perennial plant is constantly pumping organic exudates into the soil and overturning fine root hairs. So between all of those processes, there's massive organic carbon stored in the soil. Using available data, this slide shows our first pass assessment. So the total amount of carbon that's stored in Griffith's forests is equivalent to, if it were to be oxidised and all those, to 82,000 tonnes of CO2. Now that's equivalent to the annual emissions of about 5,125 Australians. So, again, as a first pass estimate, if you look at the annual increment in the growth of the biomass stock, our Griffith forest biomass carbon stock will increase by about 1,314 tonnes of CO2 equivalent per year, which is equivalent to the annual CO2 emissions of 82 Australians. So, these are measurable and significant numbers. Even though it's a small forest, it's still making that kind of contribution.